we are discussing about the synthesis of carbon nanotube techniques, in which one of the most important technique is the chemical vapor deposition techniques, where we use the coating process using the gaseous mixture which pass in the inert atmosphere and it is heated. This technique is also a very important technique so that we can get the nanotubes of the various shaped in the controlled manner. The length and the structure can be vary by varying the parameters of the method. Then this method is a most prominent method to preparation of the and the most commonly used method for the preparation of the carbon nanotubes. This is the structure, this is the schematic diagrams of the chemical vapor evaporation technique, where we use the tube in which we have the quartz vort and the sample is put inside the quartz vort, and here we see on the left hand side it is a gas inlet where we pass the methane, carbon monoxide and the acetylene gas inside the tube, and this tube is heated in the oven at the temperature 720 degrees centigrade. Hydrocarbons flow through the tube, quartz tube, and the gas outlets and deposition of the CNT is on the quartz vort, and this was first discovered by the Endo and his research group in 1993. Just he prepared the multi-wall carbon nanotubes by using the chemical vapor deposition method. Now we discuss the steps of the chemical vapor deposition method. The chemical vapor deposition techniques is achieved by taking the carbon source in the gas phase, as we are using the hydrocarbon gases just to produce the to use as a carbon source, and using the energy source such as plasma and resistively heat coil or transfer energy to the gaseous carbon molecules, as we are seeing that we are putting the this tube which is having the gaseous source into the into the oven which is having the temperature 720 degrees centigrade. It is heated at the 720 degrees centigrade. Now the second step, the CVD process used hydrocarbons as a carbon source, which includes methane, carbon monoxide and acetylene. This hydrocarbons flows through the quartz tubes being in an oven at the high temperature 720 degrees centigrade. At high temperature, the hydrocarbons are broken to be the hydrocarbon bonds, and it produces the carbon molecules, and it deposited on the quartz vort, and from there it is purified and it is extracted. Then the carbon will diffuse towards the substrate, which is the quartz, which is heated and coated with the catalyst. Usually we use the various catalysts like iron, cobalt, nickel, where it will bind, and this from there it is extracted, and this manner we can get the carbon nanotubes. Carbon nanotubes will be formed if the proper parameters are maintained. Then by using this method we can prepare the both type of carbon nanotubes, multi-wall carbon nanotubes and the single wall carbon nanotubes, which depends upon the temperature given to the tube. And the production of CWNT will occur at a higher temperature than the multi-wall carbon nanotube. The advantages of CVD process is there defined. It is having a low power output, it is in the low temperature range, and relatively high purity carbon nanotubes will be formed by CVD method. Most importantly, that we can scale up the process Means we can prepare the various size and length of the carbon nanotubes by using this method as compared to the other methods. We can, by changing the parameters, we can prepare the different lengths and different size carbon nanotubes. It may be multi-wall carbon nanotubes or it may be the single wall carbon nanotubes. Second method, which is also the most important method for the preparation of the carbon nanotubes, is the laser ablation technique. This laser ablation technique uses a pulse laser which vaporizes the graphite target in a high temperature reactor in presence of the inert gas. And these nanotubes develop on the cooler surface of the reactor as vaporized carbon condenses. On the right hand side here we are seeing the diagram. In the laser ablation method we use a laser, as the name suggests, laser ablation. Plasma will be generated by using the laser. So here we see in the diagram, this is the diagram, and in 1995 Smelly and co-workers produced the carbon nanotubes by using this ablation method, laser ablation method. Here we are using the anti-arc laser for the production of the carbon nanotubes. This anti-arc laser passes the laser beam on the graphite target, where it is put in the furnace at the temperature 1200 degrees centigrade, and the inert gas, which is argon gas, passed inside the tube. And the graphite target, when strike with the laser beam at the high temperature, then it breaks into the nanotube, and this vaporized carbon deposited on the cooled collector. It may be of the metallic rod, it may be of the quartz rod. Then here it is deposited. From this we can extract the carbon nanotubes. What are the steps behind the laser ablation method? We use the high power laser beam to vaporize the carbon from the graphite target. It means for a substrate, for a solute or for a target, we are using the graphite, which is vaporized by using the laser beam, which is put into the high temperature. To generate the single wall carbon nanotube, metal particles as a catalyst is used. Metal particles as a catalyst are used with the graphite target to prepare the SWT, single wall carbon nanotube. The laser focused on the carbon target, which containing the 1.2 cobalt or nickel with 98.8% of the graphite composite, that placed in the 1200 degrees centigrade quartz tube, and the argon gas, inert gas, is passed in this quartz furnace at the pressure 500 torr. So to prepare the SWT, catalyst added, which may be the cobalt or the nickel, and it is in the 1.2% and in the graphite composite. The temperature is very high. Also the pressure we pass in the quartz tube is also high. In such techniques, argon gas carried the vapors from the high temperature chamber into the cooled collector positions downstreams, where the carbon atoms deposited, and these carbon, when extracted, just form the carbon nanotubes. The nanotubes will self-assemble from the carbon vapors and condense on the walls of the flow tube, and the diameter of these prepared single wall carbon nanotubes from this method are 1 to 1 nanometer. It may vary from the 1.6 nanometer. Means we can prepare the nanotubes of this size 1 to 1.6 nanometer by using the laser ablation method. And by this method we can prepare both types of carbon nanotubes, multi-wall carbon nanotubes as well as the single wall carbon nanotubes. The third method, which is also used to prepare the carbon nanotubes, single and double carbon nanotubes, is the arc discharge technique. As the name suggests, arc discharge will be produced between the two graphite rod. One work as a cathode and another work as a anode. So CNT can be found in the carbon suit of graphite electrode during an arc discharge, which involving at a high current. Here we pass the high current for the discharge of the carbon particle from the graphite rod. One work as a anode and another as a cathode. This process yields the carbon nanotubes with the length up to the 50 microns. Both type of carbon nanotubes can be formed by this method. Here we see the same diagram of the carbon nanotube. On the left hand side we are having the single wall nanotubes, but on the right hand side multi-walls nanotubes are formed. By using this method, only by changing the parameters, we can form both type of carbon nanotubes, a single and multi-walls carbon nanotubes. And we see in the diagram that anode, here on the left hand side we are seeing that anode doped with the nickel cobalt. Again we use the catalyst, or we add some percentage of nickel cobalt with the graphite to prepare the single wall carbon nanotube. But in the preparation of the multi-wall carbon nanotubes we use the pure graphite electrodes. In the diagram we are seeing here the DC current source pass in the chamber which contains the high vacuum, very high vacuum, and the gas is passed in this chamber. And here we see on the top one graphite, and on the bottom we have the another graphite. On the top the graphite work as a anode, and on the bottom the graphite work as a cathode, and in between the graphite and anode and cathode we are having the plasma generated. Sometimes we use a doped if we are preparing the single wall carbon nanotube, and high temperature is maintained inside the chamber to prepare the carbon nanotubes. So from the diagram it is very clear that it passes from anode to cathode. Then from here are the carbon nanoparticles deposited on the cathode tube, and from there we can extract it. DC current pass through the anode and it is collected and it is passed through the anode to the cathode. So from diagram it is very clear, when we prepare the single wall nanotube then we add some catalyst like nickel cobalt, and when we prepare the multi-wall then we use a pure graphite. Cathode and anode graphites are used here. Current is passed at a high temperature and this arrangement put in the vacuum. So in this manner we can prepare the carbon nanotubes. What are the steps behind the arc discharge method? The arc discharge techniques generally involve the use of the two high purity graphite rods. One work as a anode and another work as a cathode. The electrodes are vaporized by passing the DC current approximately 100 ampere. And through the two high purity graphite separation 1 to 2 millimeter in the 400 millibar of the helium atmosphere. So electrodes are one of the electrodes will be vaporized by passing the current into the electrodes. After the arc discharging, for the period of the time, the carbon rods build up on the cathode. It means from the anode it is vaporized towards the cathode and it is deposited there. When it is extracted, then it is found that its texture is like a tube. That's why it is the carbon rods. That is why it is called a carbon nanotubes. This method can mostly produce the MWNT multi-wall carbon nanotubes, but for the production of SWNT, the additional metal catalyst like iron, cobalt, nickel, and many more can be attached, can be doped in the anode side. So the quantity and the basic principle of these three methods and how we can change the size and the length of the carbon nanotubes. So if we change its parameter, we can get the quantity and the qualities such as length, diameter, purity of the carbon nanotubes obtained depends upon the various parameters such as metal concentration, inert gas, pressure, type of gases, plasma arc, temperature, the current, and the system geometry. All these parameters changes the size and shape of the carbon nanotubes. Moreover, the quality and the quantity also changed by these parameters. So these parameters are very important to prepare the carbon nanotubes, like metal concentration, inert gas, pressure given to the gas inside a chamber, type of gases which we are using, how the plasma arc generated, what temperature given to the system, what current, how much current we are giving, and what is the symmetry of the system. So these parameters changes the size and shape of the carbon nanotubes, and by changing the parameters we can form the various types carbon nanotubes: single wall, multi wall, various sized wall. What are the advantages of the carbon nanotubes? As we know, this is the most prominent molecule in the carbon family, and it has many application, and it is a very many in the electronic as well as in the medical and in the various field. What are the advantages? It is extremely small and light weighted, which is very excellent replacement for the metallic wires. It is metallic wires can be prepared by using the carbon nanotubes because of its lightweight and small size. The resources required to produce them are plentiful, and many can be made with only the small amount of the material. It means we prepare the carbon nanotubes by the graphite itself. So graphite can be formed in a very cheaper manner. So this graphite can be used to produce the carbon nanotubes. And these are resistant to temperature changes, meaning they function almost just as well as the extreme cold as they do in the extreme heat. Means they can resist the temperature changes. Its function not affected by the temperature change. They can work in the high temperature as well as in the low temperature. What are the disadvantages of the carbon nanotubes? Carbon nanotubes having a disadvantages like it is extremely small, so the production is very difficult. So are difficult to work with, and it is extremely small, so preparation of this is very difficult. Moreover, the synthesis is also difficult. Despite all the research, scientists still do not understand exactly how they work or related to the carbon nanotubes. Currently, the process is relatively expensive to produce the carbon nanotubes, and the most disadvantage is in the purity of the carbon nanotubes which we prepare. It should be of the high purity for the various purposes. So carbon nanotubes having advantages as well as the disadvantages. Other disadvantages are it would be expensive to implement this new technology and replaces the older technology. Means this carbon nanotubes is used to prepare the chips and prepare the prepare the PC boards. So silicon, in comparison to silicon, it is costly. So at the rate of our technology has been becoming obsolete, it may be gamble to bet on this technology, but carbon nanotubes still using for the preparation of the electronic devices, single electron transistor and other nano devices are prepared by using the carbon nanotubes. Now we discuss the properties of carbon nanotubes. There are lots of properties of carbon nanotubes. If we talk about the strengths, electrical, thermal properties, defects is also incorporated in the CNT, and it is having a various application in the various field after incorporating the defects in the CNT. Toxicity is one of the property of the carbon nanotubes which is used in the medical purposes or in the biosciences. So in the strength, the carbon nanotubes has the strongest tensile strength as any other material, so it is called the hardest material. It also has the highest modulus of the elasticity. This is the table of the material. Left hand side we have the various form of the carbon nanotubes: SWNT, single wall, armchair, zigzag, SWNT, chiral, SWNT, and multi-wall carbon nanotubes. As compared to the stainless steel, it is having the high Young's modulus. Tensile strength is as compared to the stainless steel is more in the carbon nanotubes. So in the table we are having the various strength parameters of the carbon nanotubes and the various forms of the CWNT is also having the different parameters, like armchairs, zigzag and chiral, having the Young's modulus vary as the structure of the carbon nanotubes vary, and its tensile strength also changed. So these are the parameters as compared to the stainless steel with the carbon nanotubes, maybe single wall carbon nanotubes or the multi-wall carbon nanotubes or various types of the carbon nanotubes. What are the electrical properties of carbon nanotubes? If the nanotube structure is the armchair, then the electrical properties are metallic. It means the carbon nanotubes is metallic if the property is the same. Then in the next, if the nanotube structure is the chiral, then the electrical properties will change and it works as a semi-conducting, with the semiconductors having very small gap. As we prepare the nanotubes by using the chiral vector, then the semiconductor means we are seeing that as the structure changes, its property changes. When it is in the armchair, we form the metallic nanotubes, and when it is in the chiral form, then it is a semiconductor. It works as a semiconductor. So nanotubes work as a metallic as well as a semiconductor. In the semiconductor, we are having the small gap. So nanotubes is a moderate semiconductor. That's why it's used in the electrical industries. Other properties in the theory, metallic nanotubes can be carry and the electrical current density of the 4 × 10⁹ ampere per centimeter square, and which is more than the 1000 times greater than the metal like copper. It means it can pass the electric current as compared to the copper. Here we are seeing on the screen the 3 form of the carbon nanotubes. So there are the lots of properties of the carbon nanotubes that we discuss later. Up to now we discuss the forms of the carbon nanotubes, then we discuss the synthesis process of carbon nanotubes, and we discuss the some properties of the carbon nanotubes. Thank you very much.